Vermicomposting. The use of earthworms for composting biodegradable materials is an environment-friendly and efficient way of converting farm and household wastes into useful products. Vermicompost is an excellent soil enhancer and bioactive fertilizer for organic farming. With the abundant source of materials and the tropical conditions of the country, vermicomposting can help in protecting the environment by reducing the disposal of organic wastes. Site selection. The site for composting should have a stable water supply and the area should be flood-free. Shade is an important element in choosing the site. Ideally, shade of trees can protect the beds from sunlight and extreme heat. Alternatively, haze could be used to cover and protect these beds from strong light. It is vital that the site have good access to roads so that transportation would not be a problem. Raw materials. The materials for composting are a blend of carbon and nitrogen sources. Straw, plant leaves, and sawdust are some common examples of carbon source materials, while manure of animals such as chickens and cows and leaves of leguminous plants like ipil-ipil, acacia, madre de cacao, and peanut are among the list of material sources that are rich in nitrogen. These materials are shredded so that they can decompose easily. The volume ratio mix for these materials is 1:2 or 1:3, hence 100 sacks of animal manure corresponds to 200 or 300 sacks of plant leaves or sawdust. Piling. The substrate chambers are prepared to be filled with the shredded raw materials. The raw materials are layered according to its nature. The compiled layers are then left for a month to decompose. Throughout the whole composting process, the composting materials should be regularly sprayed with enzymes full of billions of beneficial microorganisms 3 times a week. The microorganisms speed up the decomposition process. It deodorizes and drives off harmful insects such as ants. Mixing. After a month, the layered raw materials are transferred to another substrate chamber. Through this process, the carbon and nitrogen source materials are being mixed. The mixed materials, being referred to as a substrate, are then allowed to stay in the new substrate chamber for about half a month to a month to continue to decompose. After such period of time, the substrate is then ready to be transferred to the worm beds. Bed preparation. Worm beds are usually 2 meters long and 2 meters wide with a depth of 0.3 meter. Larger versions of these are called windrows, which measure 3 meters long and 3 meters wide with the same depth measurement. The substrates are then moved to these worm beds to decompose continually with the help of the worms. 4 kilograms of worms is just about enough for a 2 by 2 by 0.3 meter worm bed. Continuous worm activity then will take place, aiding the substrate to decompose. Constant watering and spraying of enzymes with the beneficial microorganisms 3 times a week is still vital during this decomposing stage and maintaining 80% moisture. To avoid the substrate to compact, it is needful to aerate it every week. The substrate is then left in the worm bed for a month to decompose recurrently. Pre-harvesting. Harvest of the vermicompost is done when most of the materials have been consumed by the worms. These are collectively placed on the other half side of the worm bed, being ready for harvest, while allowing new substrate to fill in on the other portion of the worm bed, then let it stay for about 1 to 2 weeks. This would allow the newborn worms, along with other worms, the time to vacate to the newly added substrate. Post-harvesting. At this stage, the substrate is grainy and has a loose form compared to the mushy and compact form at the start. These are then air-dried until 30% moisture is reached. They are being screened then to separate the lump material or any unwanted particles. Vermicompost in properly packed and sealed bags should be stored in a cool and dry place. Under such conditions, the efficacy of its bioactive elements can be kept indefinitely.